and how it is resolved in arbitration. Okay, whenever processor or more than one DMA controller trying to access the bus, okay, then conflict arises. That means it requires to decide which device should be allowed to access the bus. So in that case, they are going to use the arbitration mechanism. So in that arbitration mechanism, it is going to decide so which device should be allowed for accessing the bus. By default, who is having the access to the bus? Who is the bus master? Processor. Okay, by default, always the processor will be having the mastership. Okay, whenever if any other device, okay, if it is printer, keyboard, it is not allowed. Okay, that is not having higher priority. Okay, so in that case, if it is DMA controller, then always DMA controller will be having high priority. This much we have discussed, and one thing you could have been asked one question that whenever if there is whenever if there is any data transmission takes place, okay, I told like this process is already using, it is going to suspend itself and the control is given to the DMA controller because it is having higher priority. So now I told it is going to initiate the operation and processor will be doing some other task. What type of task it is going to do? Without memory access, okay, how it can perform other tasks? Because we already know that the processor will not hold any data. Okay, always it has to get the data from memory. So when bus is busy, so it cannot use the bus for accessing the memory. In that case, how exactly the processor is going to do some other task when DMA controller, if it is performing the operation. Yes, can somebody tell? Stop talking and think what I am asking. No. First understand the question. What I told. So whenever if particular device want to transfer the data, okay. So in case if it is a DMA controller device, then it is going to get the access to the bus. And also once the processor is going to tell so what type of operation, how much data to transfer, everything it is going to inform to the DMA controller. I already told that. Okay. Then DMA controller is going to take care of transferring the data between the disk and memory. Okay. In this case, there is no interaction with the processor. I told during that time, processor will be doing some other task. Okay, what type of task it is going to do? So any task to be executed by the processor, it has to get the data or program from the memory. So now what type of task it is going to do? From registers. Okay, in case, very good. So in case if the data is stored or the operands are used, if it is registers. And also in case if the requested data, if it is available in cache memory, then it will access the data and it will execute. In case if requested data, if it is not there in the register or if it is not in the cache memory, then the processor will go idle. How long? As long as the bus should be released from the DMA controller. Okay, so this is one important point you need to remember. So I told many times the processor will be doing some other task. How it is going to do? Always the processor should fetch the data from memory. Okay, now bus is busy, it cannot fetch data from main memory. So now whatever the data, if it is available in the cache, if same thing is required by the processor, it will use it. Otherwise, it has to wait till the DMA control operation is completed. And so don't think that it is going to take more amount of data, I mean time. It will take very less time. The DMA controller, so as we have discussed in the definition, high speed data transfer. It will not take much time. That is the reason whenever if any DMA data transfer is going on, there is no interrupts are allowed. Okay, if there is an interrupt, what happens? It has to save the state of this particular program. Okay, then give control to the processor. Once it is finished, restore the state. It will take lot of time. Okay, that is the reason always once the DMA operation is started, so it will just continue till it completes. Once it is completed, DMA controller will raise an interrupt request to indicate to the processor that DMA operation is completed. Okay, for that we have discussed all what are the registers it requires, all those things. And we have discussed centralized arbitration. Two types of arbitration process. Okay, in arbitration where it is going to decide which device is going to be the next bus master. Okay, so in that first method we have discussed centralized arbitration. So where it uses the daisy chain mechanism. Okay, so whichever the device made an interrupt request. So here also in case if both the device it is making at the same time, if it is requesting the bus, what happens? So it is going to perform the logical operation, logical OR operation, similar to interrupts what you learned. Okay, it performs the logical OR operation of the request. Okay, that is sent to the processor. So now when processor is sending the grant signal, it checks that if it is DMA controller 1 is requested the interrupt, I mean the bus, so it is going to grant that request to indicate that now processor is ready to release the bus and give to this DMA controller. Okay, if it is not requested, then bus grant signal is going to propagate to the next device. Okay, this signal is going to propagate serially from one device to the other device. Are you getting? So if device 2 is alone requesting, then directly it comes to DMA controller 1. If it is not requested, how it is going to check? There will be a corresponding flags. Okay, it will check the flag. If it is not requested, it will be 0. Then it is going to send to the DMA controller 2. In case if both are requesting, always DMA controller 1 will be having higher priority. And first the processor is going to give the bus to the DMA controller 1 for transferring the data. Is it clear? Along with this diagram for centralized arbitration, see always you need to learn the diagram. Okay, once if you have how to write the diagram, if you know, so you can give the explanation, but you have to remember all the technical terms. How this process works you need to understand. No need to write as it is in the textbook. Okay, draw the diagram. So like how you have understood, just write it in your own words. Don't by heart. So that is about centralized arbitration process, and this is also I told timing diagram. The same operation it is represented in the form of timing diagram. So you need to be able to write this timing diagram and explain the centralized arbitration. So today we'll just move on to the next method, that is the second method. See, this is most of the time they've asked this question. What is arbitration, bus arbitration? Explain different types of bus arbitration methods. Okay, so just learn these two methods. So here, what is the difference between centralized and distributed is, so in case of distributed, so all the device, which are the device want to access the bus, so all the device are allowed to go for the arbitration process. Okay, so all device waiting to use, I am talking about the bus. Okay, so this bus, who can access? Is it DMA1 or DMA2 or it is processor? Okay, so in that case we are discussing about the distributed arbitration. So how this distributed arbitration works? What is the technique it is going to use? So you have understood how centralized works. Now how distributed arbitration works you need to understand. Okay, so now whichever the device it want to access the bus, so all the bus it is going to be involved in the arbitration process. Okay, so arbitration process does not depends on central arbitrator. Okay, so central arbitrator means at the processor. Okay, so at the processor where there will be arbitration process taking place, when multiple request comes, so that particular circuit diagram it is going to decide so which one to be allowed. Okay, but that is not going to happen in case of distributed. So here all the devices which that want to access the bus, so it is going to involve in the arbitration process. So what is arbitration process in this mechanism is, so each device is assigned 4-bit ID number. So we have already discussed all the devices are identified with unique ID number. Okay, so now here I am just considering it is 4-bit, it is of size 4-bit. So all devices are connected using 5 lines. So I'll just show you the diagram. Is it visible diagram? Don't worry about what is this all Okay, I am not going to explain why this voltage or resistor. I am going to just explain the process. You also don't worry about why this resistor or voltage, why this negation gate it is used. Don't worry all those things. Okay, so you are going to just understand the process. So we'll give importance to the process. So now all the devices that are connected using 5 lines. What are those 5 lines? Okay, I told each device is assigned with ID. It is of size 4 bits. Okay, to carry that address we need 4 bits. And there is one more additional line called start arbitrator. Okay, it is this line when it is active, it indicates that it is going to start the arbitration and it is going to decide which device should be allowed. Okay, so we need, there are 5 lines. So among those 4 arbitration lines used to transmit ID. So ID of the device. I'll take one example. So how that ID is used for identifying which device to be allowed. Okay, and one line indicates start arbitration. Okay, when multiple devices more than one or more than one device, if it is trying to access the bus, so it has to send the ID of those device and it has to activate the start arbitration line. So immediately it is going to perform the distributed arbitration and it will decide which device should be allowed to access. So how this mechanism works? Okay, so whenever if the device want to request the bus, so it has to follow these steps. The first step is to request the bus by a device. So first it has to assert, okay, assert the start arbitration signal and also places 4-bit number on the arbitration line, so that you can just observe here. So this is for device A. Only one device I have considered. Listen carefully. You need to understand. So which device should be allowed? So now I am going to consider 2 devices. Okay, device A and device B. Okay, so device A I will consider the ID is 5. In binary you can just take it is 0, 1, 0, 1. And for B I will assign ID 6. Okay, and I'll just represent in binary. Okay, these are the values, that is IDs of the device that should be placed on the arbitration line, that is ARB0 to ARB3. Both the device it is going to place their IDs on the line. Okay, and afterwards it is going to activate the start arbitrator. What happens? What is the next step? Now ID it is available and arbitration process started. How it is going to decide? Based on the ID. So now it is going to allow the device to use the bus based on the ID of the device. Okay, so how it is going to use the ID? So for that you need to follow this. Yes, what is the first step is? So each device compare the pattern. So yeah, what is the pattern? So before going to this, you need to understand, you need to obtain the pattern. So example, take the same example, that is device A having the ID 0101 and device B it is having ID 110. Okay, now you need to perform the logical OR operation of these 2 IDs, that is 0101, 0110. So if you apply logical OR operation, what you are going to get? 0111. Logical OR operation. Okay, if you have one more device with ID, so you have to take that also. So now, whatever you got after logical OR operation, we call it as pattern. We call it as pattern. Okay, so now I am going to use this pattern to decide, is it A device A should be allowed or B should be allowed. So what is the procedure? So each device compares the pattern that appear on the arbitration line to its own ID. Okay, and starting from MSB. Okay, so this is my pattern. I'll take from MSB, it is going to compare the ID of the device. Okay, wherever it is going to find the difference. If it is same 0, 0, if it is same, then it is okay. If it is, there is a difference, what it has to do? Just observe here. So I'll take first MSB bit. This is most significant bit. MSB bit, the comparison starts from MSB. So you just compare with both the IDs, A and B. So now take 0, compare, here also it is 0, here also it is 0. So there is no disturbance. Next bit is 1. So compare with A, okay, compare with B, it is also same, there is no issues. Next bit, okay, next bit here it is 1, in pattern it is 1, and compare with device A it is 0, but here it is 1. Okay, whichever the device that finds the next bit is 0, okay, here it is 1, it should be 1, but here it is matching, this pattern is matching with ID of the B, but this bit is differing. So in that case, what the processor is going to do is, so remaining all bits, it is going to deactivate, or it is going to disable the lights by setting the remaining bits to 0, and it will allow this particular device to access the bus. Okay, in simple words we can tell that, so whichever the device that is having higher ID, okay, 5 and 6, so that will be allowed for accessing the bus. Okay, but we cannot decide like that directly, so it requires to use this mechanism. Any doubt in this? Any doubt? So here if device detect, okay, if it detects difference means if it is not matching with the pattern. So in that case transmits on an arbitration line that it allows all lower bits position to be set to 0. Okay, it should be set to 0. And it is going to disable the request that is sent by A, and it is going to allow DMA controller B to access the bus for transmission of data. Is it clear? It's simple. You need to explain how distributed arbitration works. Draw this diagram. Okay. So you just take the same example. Okay. So device A ID is 5 and device B it is ID is 6, and calculate what is the pattern, and you just give the explanation accordingly. Okay. So that is how the distributed arbitration works. Any doubt in this? No? Okay, so next we'll move on to buses. What are the different types of buses? Before going to that, so what are the commonly asked question with respect to bus? So just note down quickly. So what type of questions you may get on topic called bus? So you can get the same topic in different ways. Okay, so those are all. I will just commonly ask question and just put in the slide. Just note down. It's visible that side. It's not simply you have to read only these questions. Okay, so these are all commonly asked questions. They can be asked in different ways also. Just note down, I will give you answer for all the questions. Make it fast. I think even you can access from MSC. I'm just creating this in MSC only. This slides are available in MSC. Okay, what is the first question? So explain synchronous and asynchronous timing diagram. 10 marks. Okay, most of the time there you will be getting the question very specific, either synchronous or asynchronous. Rarely they will ask this question. Okay, because they have not given is it read operation or write operation. So then you have to take any one operation and you have to draw the timing diagram. So you're going to learn how to draw the timing diagram. Or you may get the question like this: draw any timing diagram, okay, and explain following. That is multi-cycle synchronous bus transfer for read operation, okay, and synchronous bus for write operation. Sorry, it is asynchronous. Synchronous and asynchronous are two types of bus. There is one more question. With the need diagram, explain how data is read in asynchronous bus. Okay, the same thing it can be asked for synchronous bus.